students, how are you? We already learned about the tangents, secant, and the point of contact in the exercise 10.1. Today we learned the number of tangents from a point to a circle. See here, P is a point inside the circle. We can draw infinite number of lines through P. Do you know? We can draw infinite number of lines through a point P. If P point goes outside, okay, P is the point on the circle. Here we draw only one line. That line is known as the line of tangent. That is tangent. That means from this we can conclude that at a point of a circle we can draw only one tangent. This is the tangent at the point P. And see here, out of a point P, it is the point outside of the circle. From this point we draw two tangents, PT1 and PT2. That means outside of a point we can draw how many tangents? Two tangents. And the distance of these tangents, PT1 is always equal to PT2. Okay, students, understand this? And here we get three cases. Number one case, there is no tangent to a circle passing through a point lying inside the circle. Do you understand this? When the point is lying inside the circle, we cannot draw a tangent. There is one and only one tangent to a circle passing through a point lying on the circle. This is only one tangent we can draw. Number three, there are extremely two tangents of a circle through a point lying outside the circle. These are PT1 and P2. T2 are the two tangents where P lies outside the circle. The length of line segment, okay, from the external point P to this PT1. PT1 is known as length of the tangent, and PT2 is also the length of the tangent. And we already, I said already that PT1 is always equal to the PT2. See question from 1 to 3. Select the correct option. What is given here? Given a point Q is outside the circle, a distance OQ is given, and distance PQ is also given. Here we write given. And the question asks you to find the radius of the circle. Okay. We already know from theorem 1 that the radius is always perpendicular to the point of contact. So it is perpendicular. Okay. Okay. So we can apply Pythagoras theorem. What is the Pythagoras theorem? The square of diagonal is equal to the sum of the square of the other two sides. Here we are going to find OP. So OP is equal to root over OQ square minus PQ square. Substituting the values, we get 7. Therefore, OP is 7. The option A is correct. Then what is the question number 2? In the figure, this is a figure, TP and TQ are the two tangents to the circle with center O, and the angle POQ is given. Now we have to find PTQ. This we know that, but we learn after in the exercise that PTQ and POQ are supplementary angles. Since they are supplementary, their sum is always equal to 180 degree. Therefore, PTQ is equal to 180 minus POQ, 70 degree. So option 2 is option B is correct. Then question number 3, what is given? Question number is given 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle 80 degree, then find POA. Okay. This is the point P. Here P and PB are the tangents. Okay. And the angle between APB, what is given? 80 degree. We know that PA and PB are always equal. So we can prove that angle APO is always equal to PBPO. So the APB is 80 degrees. So this angle is 40 degrees. This angle is also 40 degrees. And again we find already in 10.1 that OA is always perpendicular to PA. So it is 90 degrees. We know that the sum of the angles of a triangle is 180 degrees. So what values of this angle and this angle we know? We have to find POA. So what is the sum of this and this? 90 plus 40. 90 plus 40 equal to 180. Sum of the angles of a triangle is equal to 180 degrees. So from 180 we subtract 130. What is find? 30 degrees. So our option is A. Students, do you understand this? If you not understand clearly, please ask me questions.